All right, let's look at the definition of linear independence. All right, so the definition is quite simple. So you have, say, set of elements of vectors in a vector space V. We said that that set is linearly independent if uh, if the linear combination of those guys happen to be equal to the to 0, which is the additive identity, then only way that can happen is that all the coefficient must be 0. Right? So we say then it's they are linearly independent, or if if you can have a non-zero coefficient and we can still get 0, then we say it's the set is linearly dependent. All right. So the following is a simple example. Let's say you're talking about a familiar R3, and that we have these three vectors, 1, 2, 1, and negative 1, 3, 4, and negative 4, 7, 11. All right. Then we can come up with a bunch of different ways, but we can come up with negative 1 times the first vector plus 3 plus the second vector plus negative 1 times the third vector is going to come out to be 0. All right. But so therefore, since we can find a non-zero coefficient that the linear combination is equaling the 0 vector, we know that this set is linearly dependent. Right? So what are the vectors that are linearly independent? So the most obvious ones, if you take vector 1, 0, 0, and say 0, 1, 0, and 0, 0, 1. So these are the most obvious ones, but we know that this guy is linearly independent. Right. Right. But how do we know that there aren't, the non-zero coefficient so that the linear combination is equaling the 0 vector? All right, so but in this case, let's try to find out the coefficient. So we say a times 1, 0, 0. So I'm just making a linear combination with the unknown constant coefficient. So I'm going to just say ABC probably. So we have that, and C times 0, 0, 1, right? And if you compute it, you see that this is going to be, so A times 1 is A times 0 is 0, A times A is 0, and B times 0 is 0, B times 1 is B, B times 0 is 0, and C times 0 is 0, C times 0 is 0, C times 1 is C. And if you add it up, we see that A plus 0 is A, 0 plus B plus 0 is B, and that 0 plus 0 plus C is C, right? But if this is equal to a 0 vector, which is 0, 0, 0, then you see that A has to be 0, B has to be 0, and C has to be 0. So we know that A is equal to B is equal to C, and also has to be equal to 0, right? So this tells you that this is linearly, linearly independent by the definition. All right, that's it. I hope that this was clear.